And one question has been discussed in the previous class related to surface integral. Surface integral is basically the double integral, and for this we require a unit vector which is normal to the surface. We have taken this surface in the previous class and discussed the question. This was the question which we have discussed. And, this is the way to find out a ds in this double integral of surface f dot n cap ds. Whether the surface is in xy plane or in yz plane or in xz plane. You will use this formula to take the value of the ds. Now, let us continue with another example we have. This is a very important example. The example is of find out the surface integral f dot n cap ds, and what is the f vector? That is 4xz I cap minus y square j cap plus y square k cap, and s is the surface of the cube bounded by the planes. The planes are x0, x1, y0, y1, z0, z1. This is the cube we have given with the 6 faces. These are the 6 faces of the cube. Now, let us discuss about the cube. This is the 3D plane we have with origin point O. This is the x-axis, this is the y-axis, and this is the z-axis we have taken. And you can draw the 6 faces of the cube like this. You just draw the cube we have. The cube is this is the cube we have. I'm just drawing with a rough hand. You please draw with the straight lines. So this is the cube we have, and name the points. This is A, this is B, this is C. So OABC is the ground of this cube, ground floor, ground, or you can say that the floor of the cube. And what is the roof of the cube? That is D, E, F, and G. This is the roof we have. Roof of this cube room. This is a square room actually, having 6 faces. And it is clear that along the x-axis we should have x equal to 1. So you can say that this is a cube of size 1. So we can say that that is the point having coordinates. This is in 3D. And you can take the coordinates of the cube as 1, 0, 0, and this is in xy plane, and xy plane 1, 1, 0 we should have, and this is in yz plane, you should have 0, 1, 1, and the point E should have coordinates 0, 0, 1. And this is the point in xz plane. So 1, 0, 1 are the coordinates. O is clear. This is origin point, and C is also clear. This is 0, 1, 0, and the coordinates of G. G is the point G should have coordinates of 1, 1, 1. So these are the coordinates of all the vertices of the cube. And now we have to move accordingly. Clearly, the surface S is given, and this surface S has been divided into 6 parts. And what are the 6 parts we have? We have 6 faces. So first face is OABC. This is the floor of the room. And the second face is DGBC. This is DGBC. This is the side along the y-axis, and the third face is DGFE. This is the face DGFE along z-axis, and the next face is OCDE. OCDE. This is in YZ plane, and the next face is ABGF. This is the plane along. This is the face along x-axis, and the next face is OAFE. OAFE. This is in xz plane. So we have these 6 faces. Now we shall discuss these faces one by one, because in each and every face we have a different unit vector. So first face we shall take, that is OABC. This is the face we are going to take. Now clearly we just see the face OABC. OABC face is lying, it is the floor, and it is lying in XY plane, and in XY plane we should have z is equal to 0, and this is the face along z-axis, and this is along z-axis. Along z-axis we should have a unit vector k cap. Along x-axis we should have unit vector j cap. Along x-axis we should have I cap. So this is along z-axis. So along z-axis we have k cap. Then opposite to that we have this floor. So the unit vector along this face should be negative of that, because it is on the negative side. So this is n cap is equal to minus k cap, and f dot n cap we can find out. This is f vector we should have. This one. This is f vector. So you can take the dot product of f vector with this, and you should have a minus of this is plus y square. You should have okay. This is a little correction there. I have wrongly written the coefficient of k cap. This is not y square. This is actually yz. Please rectify this. This is yz, coefficient of k cap. So accordingly, this should also change. So what should be the value? This should be the value y into z after taking the dot product, and it will be negative value. Negative yz will be there. And what is the z is 0. So if you put z equal to 0, you will get 0 value. So we can say that the double integral along the face OABC f dot n cap ds will come out to be 0, because this will have 0 value. And similarly we can evaluate along the other face, and the second face is we should have B, G, F and E. This is the face we are going to take now. This is the B, G, F, E. This is along the z-axis face. So along z-axis your unit vector is k cap, and this is the face which is involving this point E, and at point E z is equal to 1. You can check. So what is the f dot n cap? This should be y into z after taking the dot product. And what is the z? That is 1. So it come out to be y. So you can evaluate the double integral along DGFE. And one more thing you can evaluate ds. ds we have to find out along z-axis, but it is lying in xy plane. So that is a dx and dy divided by n cap dot k cap, and this come out to b. divided by what is the n cap, that is k cap. K cap of the dot k cap is come out to be 1. So this is a y dx dy. You can evaluate. And what are the limits of x and y along this? The limits of x and y are 0 to 1, 0 to 1, y dx dy. So this is a y square by 2, 0 to 1, and this is x 0 to 1. Ultimately it comes out to be 1 by 2. So this is the face value or the surface integral along this face. Now you can evaluate along the other face, and the next face we have to take, that is OAFE. And this is OAFE. This is the face lying in XZ plane. You just see OAFE. This is the plane XOZ. And in the plane XOZ, y is always 0. And because this is the plane in this is the XOZ plane, and what should be the unit vector, that will be negative of g, because opposite to that we have y-axis, and along y-axis we have j cap, and opposite to this side, along this side, we should have negative of j cap. So f dot n cap, we will take the dot product with the j cap, and j cap is a minus of y square into j cap, and minus sign is already there. So this is y of square, but y is 0. This come out to be 0. So the surface integral along this face to a f e f dot n cap ds will come out to be 0. So this is the third double integral of the surface integral. This question is very, very important, and similarly we should find out from the fourth phase, and this is the phase we are taking DGBC. So you just see this is a D, this is G, this is B, this is C, and C point is at y equal to 1. So y equal to 1, and what is your n cap? That is j cap, positive of that. And you can find out the dot product now. F dot n cap will come out to be y square. This come out to be 1, because the value of y is 1. Now you can evaluate the double integral along the face DGBC, and the value will be f dot n cap ds. This is the double integral within the limits 0 to 1, 0 to 1. It come out to be 1. And let us find out the ds. And ds will be, this is the face in XZ plane. If you see is, you just see the face DGBC again. DGBC. Although it is along the y-axis, but this face is lying in XOZ plane. That is why you will take dx dz, and that will be n cap dot j cap. And the n cap is j cap, so j cap dot j cap will come out to be 1. So ultimately what I want to say that this is the dx dz. These are the limits of x and z. So you can integrate and you will get 1. So this face DGBC has a surface integral 1. Now the next face is OCDE. This is OCDE. You just see the face. This is the face OCDE. And this face is a line in Y, O and Z plane. And in Y, O, Z plane, x should be 0. And if x is 0, what will be the n cap? N cap will be negative of I cap. And what should be f dot n cap? And f dot n cap should be 4x z negative. You can take the dot product with n cap. And n cap is a negative I. And what is the value of x here? That is 0. So this comes out to be 0. So the double integral along this face OCDE will come out to be 0. Now the last face we will have, that is ABGF, and this is the face we have. This is the face ABGF, and this face is lying along x-axis, and it is lying along x-axis at x equal to 1 and n cap is equal to I cap. So f dot n cap will come out to be, and this come out to be 4xz. X can be substituted as 1, so it come out to be 4z. And now you can, because this is the face lying in, this is the face ABGF, but this is the face along x-axis, but it is lying in YZ plane, Y rho Z. So you will find out ds accordingly. So ds will be dy dz and the dot product of n cap with I cap. So dy dz, what is n cap? I cap. So I dot I, that come out to be 1, and its absolute value will also be 1. So you can evaluate the double integral now. Double integral f dot n cap ds along the face ABGF. This is the double integral 4z dy dz within the limits 0 to 1, 0 to 1. Because y having limit 0 to 1, z is also having limits 0 to 1. 4z square upon 2, 0 to 1, and it is y 0 to 1. So this come out to be 2. After substituting the limits, you will get 2 here. So you have the you all have the surface integral along 6 faces. First phase has 0 surface integral, second phase has 1 by 2, third phase has 1, and the fourth phase has 0, fifth phase has also 0, and this has 2. So you can add up all the values. So what it come out to be? Add up all the values, that is 2, it is 1 by 2, equal to 1. So adding up all the values, we should have f dot n cap ds along the surface S. That is 1 by 2, 0 plus 0 plus 1 plus 0 plus 2. So this comes out to be 6 by 2, that is 3, 3 to the 6 plus 7. 7 by 2 is the surface integral value. So this is the value we have. Okay. One more thing. We have taken f dot n cap in this phase again. This is the phase DGBC. In DGBC, we have to find out f dot n cap, and probably n cap is j cap. Okay, this is a negative y square. This is, let's see, this is negative y square, and wrongly I have written here this is a positive y square. So this should be negative. So that value should be negative 1. Please make a correction here. So this value should be negative 1. So now this value will also come out to be negative, and little change will be there, and this will have 0, negative 1 value, from then 1 and 1, and that come out to be 3 by 2 value. So this is the correct value they come. So by this way we can evaluate the surface integral along the 6 faces of the cube. So this is very important question. And, I stopped my class here. We shall continue in the next class tomorrow. Thank you very much.